Unit 7, Day 2. A lot of overlap with yesterday. I did that intentionally to try to make today a little bit easier. So a lot of what we do today you saw a little bit of yesterday, but what we're going to do today is to write equations. Yesterday we gave you the equations and you wrote the terms. Today we're going to kind of switch that around. We'll give you the terms and you'll write the equations. And we've seen it before a little bit, so it's somewhat familiar. Again, the two main types are arithmetic and geometric. We saw the formula yesterday, the nth term. Let's see, we start with the first term, and it's arithmetic, so we're adding. Arithmetic has a common difference. And how many times do I need to add that common difference? Do you remember? N minus 1, right? Because we're starting at the first term. So if we want to get to the 8th term, we got to add 7 times to get there. So it's that n minus 1 thing that is what kind of throws people off. But if you'll remember that you're starting at the first step, so to get to the 12th step, you need to take 11 more steps. So it's always one less to get to where you want to go. So let's write the formula for 37, 49, 61, 73, ... So let's follow the pattern here. So we have to identify A1 and D, and then we'll be ready to write the formula. So A1 is the first term, that's 37. Common difference is 12, 12, 12. So now we're ready to write the formula because we have the first term and we have the common difference. So 37 plus 12 times n minus 1. And some debate on whether you want to leave it like that or clean it up. I'm okay either way. It kind of depends on the problem and if you need to do anything more as to what's better or not. So you can leave it like that. We'll do some things later where it might be better if you clean this up. So this is an okay answer. But it's also okay if you want to distribute the 12, combine like terms. So that would be 12n plus 25. Either answer is okay, and it kind of depends on the problem as to which one's better. So if it just plain up asks for the equation, probably leave it at the first one and don't mess things up. Later, we're going to do more stuff with them, and it might be easier if it's in this format, but either one is okay. This one looks simpler, but when you leave it like this, it's easy to see what A1 and D are. When you put it in this format, you've sort of lost A1. I guess you could still find D, but A1 is gone. And so all that to say, either one is fine. And in fact, on the key for today, I think I wrote both of them for all of them. So you can check it either way as well when you're looking at the key. All right, so that's pretty straightforward. If we, because you can read off A1 and figure out D pretty easily, and then plug them into the equation. We can try to get it a little bit trickier if we don't give you A1. If we give you things like A7 is 24 and A11 is 40. Well, then I don't know what A1 is, and I don't know what D is. So there's sort of two ways to work this problem, and I'll work it both ways, and then you can decide which way you think is more suited for your taste. The first way is the more straightforward way. It takes a little bit longer, but it's more straightforward. It's more formulaic. It's more, just do the process, same thing every time. The second way is a little bit shorter, but you have to understand what's going on. Again, we'll do them both ways. So let's write the formula for the 7th term. So that means 24 equals A1 plus D times 6. All right, I don't know what A1 is. I don't know what D is. But to get to the 7th term, I start with the first term. I add 6 differences, and I would land at 24. And if we write the 11th term, or the 11th term formula, again, we start with A1. How many times would we have to add the common difference to land at the 11th term? 10. So now we have a system of equations. Let's multiply the top one by -1. So then we get -24 equals -A1 minus D times 6. And the reason we did that is so that the A's will go away, so the A1s will go away. So 16 equals, 10D minus 6D would be 4D, and the A1s went away. So D equals 4. So there's part of what we need to know. All right, we're trying to get to A1 and D so that we can write the formula. So let's take our 7th term formula here, because we know what D is now. D is 4. 6 from the formula. That turns out kind of weird, maybe. What is A1 going to be? It's got to be 0. It's the only way that will work. So now I have D, I have A1, so A sub n equals the first term plus 4 times n minus 1. And again, you can leave it like that if you like. Maybe that looks weird, but it's the format that's easy to tell what A1 and what D is. So that is an okay answer. If it bugs you and you feel like you need to distribute and collect like terms, especially with the 0 sitting there, then you could change it to 4n minus 4. Either one is okay. It's the same thing, it's just written differently. Okay, that's the kind of straightforward way to go about that. There's nothing wrong with that way. It's a good way. And really, if you struggle with math, that's the way to go. Because the other way requires a little bit more thinking. It requires less pencil on paper, but it requires more brain work. So again, I'll let you decide which way suits you best. Method 1, method 2. And again, this is if you don't have the information that you need, if you're trying to figure out A1 and D. All right, method 2. So I'm at the 7th step, or I'm at the 7th term. How many times do I need to add to get to the 11th term? 4. So if I'm at 24, because that's the 7th term, and I add 4 steps, 4 differences, I should land at the 11th term. So it kind of short circuits a little bit of the longer work the method 1 does, but it's the same idea. If I start at 24, I take 4 steps, I land at 40. So 4D equals 16, D equals 4. And that matches, so you feel good there. But then I still need to find A1. So if I start at the 7th term, and I want to back up to the first term, how many differences does it take to get back to the first term? How many steps do I need to back up? 6. So I need to back up minus 6 differences to get to the first term. Let's see, the 7th term is 24. We already know what the difference is. If we back up 6 fours, if we back up 4 6 times, we land at the first term, and that's what we're looking for. So A1 equals 0. So we take our D1 and our A, and we can jump in and get the equation that way. I prefer method 2, because I don't think it's too hard to think about. Well, if I'm at the 7th term and I want to get to the 11th term, that's 4 steps away. But then I need to think about backing up to get back down to the first term. So again, method 2, a little more intuitive, a little quicker. Method 1, a little more formulaic, a little more process-oriented. You pick which one works best for you. All right, that's the arithmetic section. Let's do the geometric section. Remember, it has to the trained eye, a somewhat similar formula. To an untrained non-math person, they would think they look nothing alike. But we know there's some similarities there. We start with A1. And arithmetic, we added each time. Geometric, we're multiplying each time by the common ratio and n minus 1. So we're going to do the same 2 kinds of things here, right? The formula for one where we just give you some terms, and for one where we kind of hop around a little bit. First sequence, 2, -6, 18, -54. So let's see, again, we need A1 and R. Well, A1 is 2. That's the first term. What's the R? What are we multiplying by each time? -3. Careful with the negative. You saw this yesterday. When it flips signs, that means you're multiplying by a negative number. So A sub n is 2 times -3 to the n minus 1. Make sure that R is in parentheses, especially if it's a negative. That way you're squaring a negative, not squaring it and then staking the negative on there. So be careful with negatives and fractions. Make sure they're in parentheses. Also, no one's going to say that I can multiply those and get -6, right? That doesn't work because that has an exponent on there. So just leave it like that. And there's nothing more you can do with that one. It's not like the arithmetic one where you can distribute and rearrange some things. Like you're kind of stuck. I think I'm going to go ahead and write it and mark it out anyway. You can't do this. You can't multiply those, right? Because there's an exponent that you have to take care of first. All right, the second one. It's going to be similar to the second one from the arithmetic section, where you don't have A1 and R. You've got 2 random terms, and you got to figure out how we got those. A2 is 2, and A5 is -16. Again, I'll do the 2 different methods. First method is use the formula. Plug things in. So our second term is 2. That equals A1 times R to the first. fifth term is negative 16. That equals A1 times R. See, if we're at the fifth term, we started at A1. It takes 4 steps to get there, so R to the fourth. Now, combining these is a little different than combining with arithmetic. The arithmetic combination is a solution method you've done before, where you eliminate a variable by adding and subtracting. Here, we're going to divide by the first equation. Because when we divide by it, A1s will go away. So it's a little bit weird, but instead of adding equations together, we're going to divide an equation. Negative 16 over 2 is negative 8. A1 over A1 goes away. That's why we're dividing. A1's gone. What's R to the fourth divided by R to the first? R to the third. So that means R equals negative 2. And so we found our R. Now we need to figure out what A1 is. We can grab one of those equations. 2 equals A1 times negative 2. I guess to the first, but that doesn't add a whole lot. Divide both sides by negative 2. And A1 is negative 1. So we've got R, we've got A1. So A1 times R to the n minus 1. And again, don't mess with those. Don't say negative times negative is a positive. I mean, that's a true statement, but that's not what's going on right there. So leave those A1 and those R's in parentheses is probably the safest way to go. All right, back up. Let's do method 2 for those that have a little more intuitive feel of what's going on here. To get from the second term to the fifth term, how many times do I need to multiply by R if I'm going from step 2 to step 5? That's 3 steps. If you're really struggling with it, you should probably use the other method, but 1, 2, 3, 4, 5. If you need to count them out, you can kind of write out blanks and say, well, from the second to the fifth is 1, 2, 3. So second term times 3 R's would get me to the fifth term. So again, it's the idea of where am I going, how many steps does it take to get there? So 2 is the second term. Negative 16 is the fifth term. So 2 times R cubed equals negative 16. So R cubed equals negative 8. And R equals negative 2. So I'm multiplying by negative 2 3 times to land at negative 16. And then my second term, I'm trying to get to A1, so I would need to divide by R 1 time to back up once to the first term. Again, maybe drawing it out helps, because you could also fill in the blanks there if you needed to. You're like, well, I need to back up one, so I'll divide by negative 2. And A1 is negative 1. So again, that second method I think is a little quicker if you understand the idea of well, if I'm on the 5th step and I want to get to the 12th step, that's 7 steps away. But then I need to back up to get to the first step. So if you can handle those forward and backwards things, it's probably the better method. But if you need to write out formulas and do a more kind of a procedural task, then the first method is fine. Either method is fine. But I think once you get the hang of them, the second method is probably a little easier to deal with. All right, today's assignment is worksheet 2 in the packet. Again, online, the packet is grouped together. And just this morning, I added the odd answers to worksheets 1 through 4. So you can check those online. Again, it's in the main folder for the Unit 7 in Schoology.